This is an AS multiple choice question, and we are looking at reversible reactions and dynamic equilibrium. So we need to go through all of the information carefully. We know the forward reaction is endothermic. We know that we start with 1 mole and we end up making 2 moles on the forward reaction. And that might well be useful as we begin to evaluate the 4 different options, only one of which can be correct. So if the total pressure is increased at constant temperature, the proportion of Cl2 in the equilibrium mixture will decrease. That's not the case. What happens is the equilibrium will shift until we revert to the same ratios. So there will be more of it, but the ratios will be identical. Use of a catalyst will increase the proportion of CoCl2 in the equilibrium mixture at constant temperature and pressure. Well, the catalyst doesn't have an effect on the position of equilibrium, so that can't be the answer either. It will speed up the forward and reverse reactions equally by reducing the activation energy for each direction equally. Reducing the equilibrium concentration of CO will increase the value of the equilibrium constant. Well, Kc is dependent on temperature only, so that can't be the answer. We actually get to D, and we see that there's a relatively straightforward way of getting to the answer without going through all of that. But I think it is important that we understand why they're wrong. The forward reaction is endothermic. If I increase the temperature, that will favour more product. So my concentrations of CO and Cl2 will go up, and my concentration of CoCl2 will go down. Now, if I just consider putting those numbers into the expression for Kc, I can see that that will cause the equilibrium constant to go up. The very quick way of answering this question is that we remember that Kc is dependent on temperature and only dependent on temperature. And D is the only place where temperature is changing.